The next model we're going to discuss is exponential smoothing. Like the previous two, naive model, moving average, even the weighted moving average, is like those models. Exponential smoothing model is also suitable only when there is no trend or no seasonality in the time series. Only random fluctuations, then exponential smoothing is one of the models that you should consider. Exponential smoothing does not handle trend or seasonality well at all. Exponential smoothing is a kind of weighted moving average, but we don't choose the weight for previous time periods for each of the previous time periods. There is only one weight, and that weight is called the smoothing constant alpha, and based on this alpha value, the formula for exponential smoothing automatically assigns weights for the past sales data, and that weight decreases as we go further and further into the history past periods, and it declines in an exponential fashion, and that's the reason why it is called exponential smoothing. And this constant alpha is a value between 0 and 1, and the forecaster has to choose a value, and we will talk about how to choose a value in just a little bit. Now this is the formula. So forecast for any given time period is the forecast for the previous time period, okay, plus alpha times the forecast error in that previous time period. So it is the previous forecast plus a portion of the error. Now when you use alpha in this fashion, the weight that implicitly the formula assigns to the past actual values will go like this. Suppose if alpha is 0.1, so the most recent actual value will get a weight of 0.1, and the one before that is 0.09, and the time before that is 0.081, and so on. It declines in a kind of a gradual exponential fashion. If alpha is 0.5, then this will be the decline in the weights that the formula implicitly assigns. Even though theoretically alpha can be any value from 0 to 1, generally speaking, this is the range in which one would choose an alpha value. But this is a subjective choice. Now let's work a problem out. So let's work this problem, exponential smoothing. Remember, the formula is f sub t is f sub t minus 1, the previous forecast, plus alpha times a sub t minus 1 minus f sub t minus 1. So that's the previous error. Now we have to start with some forecast for the very first time period. The initial forecast must be known. In many instances, this will be available in the company records. Otherwise, you have to make up reasonable forecast for the very first time period. Here we are given that the first time period forecast is 22. So the error is 20 minus 22 is equal to minus 2. So forecast for period 2 is the previous forecast 22 plus alpha. We're going to use an alpha of 0.8. So 0.8 times the error. So remember, this error is a sub t minus f sub t. So that's what we're going to use here, minus 2. Then we get 20.4. Then 21 minus 20.4, that's the error, and that's equal to 0.6. Next is f sub 3, previous forecast, plus alpha times the error from here, 0.6. So that gives us 20.88. So then the error is 15 minus 20.88, and that is equal to minus 5.88. Then f sub 4 is 20.88 plus 0.8 times minus 5.88 gives you 16.176. Now the error is 14 minus 16.176 is minus 2.176. F sub 5, 16.176 plus 0.8 times minus 2.176 gives you 14.4352. Then the error is 13 minus 14.4352, and that is equal to minus 1.4352. And f sub 6 is 14.4352 plus 0.8 times minus 1.4352 is equal to 13.287, and 16 minus 13.287 is equal to 2.713. Then for July, then f sub 7 forecast for July is 13.287 plus 0.8 times 2.713 is equal to 15.4574. Now if you find the absolute value of these errors and average them, then you get MAD. I'm not going to show you the computations, but I'll just give you the value of MAD, 2.4674, and MAPE is 15.93%. Now, how do you select an appropriate value for alpha? Okay, alpha can be anywhere between 0 and 1 theoretically, and in a practical sense, you choose a value maybe somewhere around 0.05 to 0.5, or maybe a little bit higher than that. One other consideration that we can look at is how alpha will impact the forecast. Larger the value of alpha, so the blue line being the actual sales, larger the value of alpha, the forecasts tend to follow the actual value very closely. So if alpha is equal to 1, then the forecast is actually equal to the previous actual value, which is naive forecast. So if alpha is equal to 1, the impact of that would be to render exponential smoothing the same as naive model. On the other hand, if alpha is equal to 0, then the forecast doesn't change at all. Forecast for time period t is the forecast for the previous time period and the one before that, and they'll all be exactly same. So if alpha is 0, forecast will be exactly same, no change at all, so that is stable. And if alpha is equal to 1, then it will follow the actual sales with a lag. So we have to keep that in mind when we select a value for alpha. Of course, the most important consideration is to try different alpha values and choose the one that has the smallest forecast error. Like MAD is the smallest, or MAPE is the smallest. So you need to try different values of alpha and choose the one that has the smallest possible alpha value. We can use solver, like in the project management, we use solver for critical path method for crashing. We can set this up in, if exponential model is set up in Excel, then we can run solver to find the best alpha value that will minimize the value of MAD.